When you are trying to identify an intercept from a graph, you need to look at the point in which the graph crosses or intercepts the x-axis or the y-axis. Just keep in mind that it's possible to have multiple intercepts on a single graph. So if we have this graph here, we want to identify where they cross the x-axis and the y-axis. So let's start off with where it crosses the y. It crosses right here at -4. So we can say that the y-intercept, and you always want to write it as an ordered pair typically, is at x being 0 and y being -4. Whenever you have a y-intercept, the x value is always 0, always and forever. Now let's look at the x-intercept. The x-intercept is where the graph crosses the x-axis, and it crosses right here at 2. So the ordered pair that shows the x-intercept is going to be 2, 0. And when you cross the x-axis, the y value is always 0. So this is a fundamental fact. When you cross the x-axis, y is 0. When you cross the y-axis, x is 0. And here are your x and y intercepts. Here we're given this graph. It's a nice curve, up, down, and up again. Again, we want to know where it crosses the x and where it crosses the y. So the y-intercept, we see that it crosses right here at -1. So we know that if it crosses the y-axis, x has to be 0, and the y value is -1. So the ordered pair is 0, -1. Now for the x-intercept, we see that it crosses 2 times. Right here and right here. Even though it doesn't technically cross it here, it touches it, that still counts as an intercept. So starting over here across at -1, so we know the order pair is going to be -1, and again the y value has to be 0 because we're touching the x-axis. But it also crosses right here, so we could say that the x-intercept here is 1, 0, because again the y value will always be 0 for the x-intercept. So in this one we have 2 x-intercepts and we have 1 y-intercept. Again, it's possible to have multiple x-intercepts, but if you're dealing with a function, you should have only at most 1 y-intercept.